Hello and welcome back to the course on blockchain. And today we're going to be talking about mining. This is going to be a two-part tutorial. All right, so let's have a look where we are on our map. We've talked about hash cryptography, the immutable ledger. We've now also checked off distributed peer-to-peer networks. And finally, we're moving on to the mining. In these two tutorials, we're going to find out exactly what the whole system is about. Why is there mining? What's the competition that everybody's participating in? Why are so many resources allocated or dedicated to mining blockchain and bitcoins and things like that? So let's have a look. Here is our block in a blockchain, and as we discussed, it's got a couple of fields. So it's got the block number at the top, it's got some data, and as you can see here, I've put in some fake data where I sent Adlan 500 AdCoins, then I bought something on eBay for 100 AdCoins. Adlan sent some person named Joe 70 AdCoins. And what AdCoin is a cryptocurrency that you'll be creating together with Adlan in module 2 of this course. It's a short preview of the exciting stuff that's coming up ahead. And something I wanted to point out here is that notice how I put not just one transaction into this block, but several. We'll discuss this in more detail in module 2, but it's already a good idea to keep in mind that a block doesn't just store one single transaction. A block stores multiple transactions, so several transactions get put into a block, and then the blockchain moves on to the next one. So just something to keep in mind, and we'll discuss this in more detail later. Then also in the block, we've got a field for the previous hash, or the hash of the previous block. And this is a very important feature of blockchains because that's how the cryptographic link is facilitated between them. Without this field, the blockchain wouldn't be a blockchain. And finally, we've got a field for the hash of the current block. And how do we get the hash of the current block? Well, we take the block number, the data, and the previous hash. We put all of that together into a hashing algorithm, and it spits out a hash for us. And there it is. That's our hash. And so here, this instantly asks for a question. And the question is, if it's so simple to just take the block number, the data, and the previous hash, put into a hashing algorithm, and get a hash out, which takes like half a second. If it's so simple, then how come, what's the whole fuss about mining? How come there's so many, hundreds of thousands mining rigs around the world, or nodes around the world, and lots of mining rigs and a lot of computational powers dedicated to them? Why is this all happening, and what's this competition that everybody's in if this is all there is to mining a block? Well, in reality, it's not as simple as that. There's actually another field in a block, and it's time to reveal this field. The field is called Nonce, and Nonce stands for number used only once. And so this field is what mining is all about. As we'll see from this tutorial and the next one, everybody is just changing this field all the time. So to understand this, let's have a look at what is it that now controls the hash? What is it that now dictates the hash of the block in this new updated structure that we see? Well, it's these things highlighted in the green square. We've got the block number, the nonce is now included in that party, and then we've got the data and the previous hash. So now we take all these four components, so we put them into a hashing algorithm, and then it will spit out the hash value. And so all of a sudden, now what the nonce gives us, it gives us extra control, gives us extra flexibility. Now we can manipulate the hash value by changing the nonce. So we don't have to change the block number. We can't change the block number because the block number is the block number. We can't change the previous hash because it's linked directly to what we have in the previous block. And we can't change the data because that would mean we're tampering with the data, and that would defeat the purpose of a blockchain. It has to be an immutable ledger. We want to prevent tampering. So now, because we have the nonce, we are free to change the value of the nonce, and the nonce is just basically a number. We're free to change the value of the nonce, and that will allow us to change or to manipulate the hash, to vary the hash. The proper word is vary because, as we know, the hashing algorithm, we cannot predict in advance what it'll spit out. We put in a nonce, and it will spit out something. So we cannot control the hash, but at least we can vary the hash by varying the nonce. So let's have a look at how that works. So let's put in 19. So here, let's go back for a second. So nonce is like 0 right now. It's empty, and that's why we have a certain hash. Then we put in like a random number, 19, we get a hash, a different hash. 20, different hash. 21, again, different hash. 22, 23. Then we can do like, oh, something I wanted to point out here. So you can see that the hash is changing, and also notice how when we go from, let's say, from 21 to 22, notice how the hash is changing absolutely like dramatically. And why is that happening? Well, that's the avalanche effect in action. What's happening is in the block itself, essentially we're just changing one bit of information. So if you write it out in binary code, you'll see that this block has like some combination of ones and zeros, and to go from this to this, we're just changing literally one bit somewhere from a 0 to a 1. And that is that's all with the chain we're doing, but at the same time the hash is completely unrecognizable. It's completely different to what we had before, and that is important. That will be important, why we'll see in the next tutorial, but that's the avalanche effect in action. I just wanted to illustrate that. Okay, so that's how we change the nonce. So let's take a random number. There's 243, like there's 10,955. So nonce is a number that can go up to like 4 billion something. So it's quite a large number. There's a lot of variety that you can play around with the nonce, and that gives you variability in the hash. So there we go. That's a start to mining. We'll end the first tutorial of this two-part series here, because that was like an important concept, that the blocks have nonce, which we can control, we can change to vary the hash. And in the next tutorial, we'll put it all together, and you'll see why exactly that's important and what the miners are actually doing with their electricity and with all their hashing power. All right, so I hope you enjoyed today's tutorial, and I look forward to seeing you next time. Until then, enjoy blockchains.